Okay, the next thing we are going to discuss about is Coulomb's law relating to order force field. Coulomb's law relating to order force field. Now, there's something important or very shocking about Coulomb's law. And what is that? Recall that Coulomb's law is also talking about bodies. It's talking about when you have two bodies, probably we have a positive and we have a negative body. So you expect that there should be a kind of attraction between these two bodies according to electrostatic law that states unlike charges attract each other. And likewise, when you see a body that have the same like, you expected that these two charges should repel one another. So Coulomb's law is majorly talking about two bodies. And in physics, we also have other two bodies. And one of them is called the universal gravitational force. So we're going to start with the universal gravitational force. Coulomb's law and universal gravitational force. Now, quick one. Starting with Coulomb's law. For Coulomb's law, it states that when we have the force of attraction or force of repulsion between two charges, it is actually directly proportional to the product of the charges and inversely proportional to their distances, to the square of their distances. And we later knew that this actually produced F equals to K Q1 Q2 over R squared. When we're coming down to the case of gravitational force, which is referred to as universal gravitational force. Now, universal gravitational force was actually discovered by a man called Sir Isaac Newton. Now, Sir Isaac Newton says that the force of attraction and also repulsion between two heavenly bodies is directly proportional to the product of their masses and inversely proportional to the square of their distance. And later on, the proportionality sign produced a constant, and that constant is referred to as universal gravitational constant, and that's G. Now we have M2 and M1, then R squared. So look at this carefully. Both of them are talking about two bodies. One is talking about two charges, and this one is talking about two planetary bodies. So these are the two relationships. So we can actually equate their forces together. So let's do that first. Okay, so let's equate the forces together. Recall, let's symbolize that of Coulomb's law as E, because majorly it's talking about electrostatic, and that of universal gravitational law, let's call that Fg. So let's try to relate their forces together. So I say Fe is equals to Fg, and recall, Fg there, and recall that Fe is equals to K Q1 Q2 over R squared, and that of Fg is equals to G M1 M2 over R squared. So we can try to equate that here. So we can say K is equals to Q1 Q2 over R squared, then equals to G, which is G M1 M2 over R squared. So in this case, when we try to cross multiply, there's something that is going to happen. In our cross multiplication, we're going to have it as G, okay, let me start with K now. K Q1 Q2 then R squared equals to G M1 M2 then R squared. So you'll notice that R squared is common at the both sides. So the R squared can cancel out the R squared. So when they cancel out, we are just left with. When they cancel out, we'll be left with just K Q1 Q2 then G M1 M2. Now there's a good question they usually do many times. They try to compare the K and G. So in doing that, I can say the ratio of K to that of G, we end up having M1 M2 over Q1 then Q2. So this is just simply the universal gravitational constant, likewise that of Coulomb's constant. But before then, we have already learned one. Another thing I love to talk about, let Abel say to find Fe, then Fg. So in doing that, you should know that Fe should be Gm1, M2, then Fe will be K, Q1, Q2. You know why I'm doing this? Because when you later cross multiply, you're going to have Fg is directly proportional to Gm1, M2, then we're going to have Fe is directly proportional to K, Q1, Q2. And at this side, the arrows that mean the distances would have cancelled out. So these are the things we should know anytime we are dealing with Coulomb's law and universal gravitational force.